Okay. Welcome again in the third session of the day. Yesterday we talked about growing energy demand and challenges before us, and we briefly also discussed about the measures that we can take. So today's this session is an extension of yesterday's the session on growing energy demand and challenges, and the topic is passive solar ventilation, and the expert speaker Dr. V. N. Bartaria is with us. So I welcome Dr. Bartaria, sir, and I would like to give brief about sir. Bartaria, sir, is professor and head of the Department of Mechanical Engineering Department, LNCT Bhopal. He has 27 years of experience working with reputed industries and engineering institutions and technical education department. He has more than 220 publications in and 158 in international journals, 225 in national journals, 22 in international conferences, and 16 in national conference. His consultancy and research areas include design and analysis of engineering systems involving fluid flow and heat transfer, solar energy collector design, performance analysis, design and performance analysis of heat exchanger, solar electric energy conservation, HVAC system design, and problem identification, formulation, and solution for engineering systems involving heat and airflow in the indoor and outdoor environment. So, again, I welcome Dr. V. N. Bartaria, sir, for the session. Sir, please take charge of the session.
Thank you, madam. So, good afternoon to each and everyone. I hope all of you must have joined the last session which I had taken yesterday, in which we had discussed about the growing energy demands in India, particularly, and the associated environmental challenges. And I had also suggested some solutions so that we can get the sustainability in environment. We can get our environment clean for the future. And I had suggested several ways we had discussed, and we have seen the growing energy demands and associated fuels, requirements of fuel, and burning of. We have seen that huge energy demands are coming in future also. Our demands of energy are going continuously increasing, and in coming years a great demand of energy will come before us, and to meet that requirement we will be definitely depending upon the conventional fuels such as coal, oil, and gas. And we are also, our government is also focusing, planning, and making best efforts to uh, adopt the renewable energy sources, renewable energy systems, and government is continuously making efforts to uh, increase the percentage of share of renewable energy sources in uh, providing the in completing the requirement of total energy needs of the nation. So today, in the continuation of that session, we can say we are going to learn some techniques, discuss some techniques. I will show you, I will make you aware of some of the technologies which are totally based on renewable energy. And by using those techniques, we can get the we can reduce the requirements of conventional energies, which is electricity obtained from fossil fuels mainly, and we can contribute our efforts in the sustainability of environment. And these technologies are not new. You will see that these are not new. They were used in earlier days, olden days, in decades ago, in centuries ago, in fact. And they had become obsolete because of the easy availability of the conventional energy, electricity, and the ease in obtaining the our access. In fact, in urban areas, we are easily having electrical energy, and so we were more relying upon the conventional systems. We are more relying on the active systems, which are consuming electricity and giving us the comfort, as well as completing our day-to-day routine fulfillment of our requirements. So I just share my PPT. So is it visible to all, my PPT presentation?
Yes, sir.
Okay. So we are going ahead with the passive solar ventilation. Passive solar ventilation system. So to come to this topic direct, to before coming to the contents of this topic, few things I would like to share and discuss with you. That electricity generation in India is having the great increase in over the years. India has now become the uh, third largest third largest producer of electricity in the world after China and US. India has an installed capacity of 388.134 gigawatt as of 31st August 2021. So India is at a good position of production and consumption of electricity, conventional energy. So at present, China is at the top. After China, United States is there, and India is at the third place. Electricity generation in the year 2020, uh, as per the records of electricity generation in the year 2020. So we can see that we are at the third place in the generation of electricity. Also, we are a good consumer also. If we see the consumption of electricity in India, that we are also consuming good electricity at to fulfill our requirements, human needs, human activities. And if we see the installed capacity by source, by the basically depending upon the fuel used to produce the electricity in India, as on 12th December 2021. So we see that share of coal is major. If we see the installed capacity, so coal-based power plants are sharing 51.7%, while hydro power plants are having 11.9% share. Wind, solar, and other renewable energy sources are having 26.5% as the installed capacity. Gas 6.4%, nuclear 1.7%, and diesel is very little, 0.1%. So total the major electricity generation is based upon the coal. So coal is basically burning of coal or combustion of coal in thermal power plants is the main source of getting electricity in India. And we had also discussed yesterday that with the burning of coal, with the combustion of coal, we are polluting our environment. We are getting air polluted, and simultaneously the pollution or contamination of water, soil, and ambient air is uh, also taking place because of the combustion of coal. Apart from combustion of coal in powerhouses, the burning of wood uh, in cooking for the purpose of cooking of food is also a major source of pollution in India, and air is getting polluted because of the combustion of conventional fuels apart from coal, such as biomass, wood, etc. So the condition of air in India is getting very much polluted, and we have also seen yesterday that the clean air days in several cities of India are very few. Some are having less than 50 days as a over in a year as a clean air days, and many cities are having very few number of days in which they get the few clean air. So the conditions of air are now very challenging. We have to take care of the pollution immediately, and our efforts are not sufficient to get the good environment or clean environment, green environment, where we can live happily, or we can uh, keep our health uh, in a good condition. Air pollution is a major source of diseases also in India and throughout the world. India at present, uh, if we see the energy consumption, that we have seen that India at present is the fourth largest global energy consumer. We are generating we at in case of generation, we are at the third position, and at in the if we see the consumption of energy, then India at present is the fourth largest global energy consumer behind China and United States and the European Union. So India will overtake the European Union as the world's third largest energy consumer by 2030, according to the International Energy Agency (IEA). So I had told you that IEA is the International Energy Agency, is an autonomous intergovernmental organization. India is a corporate member of IEA, and IEA is working in close coordination with the governments of different nations in uh, uh, in the formation of policy, energy policy, economic development, energy security, and environmental protection also. So they are suggesting, they are providing solutions in framing of policies, in providing the useful data regarding energy production, energy future requirements, energy security, and environmental protection also. So IEA mainly focuses on its energy policies, which include economic development, energy security, and environmental protection. These policies are also known as the three E's of IEA. So the outcome of IEA report is very valuable for any nation to further make policies regarding energy, and to prevent the atmosphere also from pollution. Now we see the indoor air quality. So ultimately, we will see the importance and the techniques of passive solar ventilation. But before that, we are going to learn about some of the things which are very essential to know. Then only we would be able to understand why we have to go for the passive solutions in place of active solutions. So active systems are there, but if we go to adopt the passive systems, then we can save our environment, we can save our resources, we can conserve our natural resources, and we can live in a clean environment. So to understand that accurately and clearly, we need to know some things which are very relevant with passive solar ventilation system. Indoor air quality, IAQ. This term everybody must be knowing IAQ nowadays, because frequently we see the air quality index. uh, which has now become very important for several cities. If AQI becomes higher, then the living condition and the air conditions become so worse that it becomes difficult for the common person to breathe and because remain healthy. So the indoor air quality means the airborne contaminants inside a building, which is a crucial factor that determines the quality of the indoor environment. So indoor environment is determined from the airborne contaminants inside a building. And indoor environment is very much neglected. It is not considered by the by a common person in India. It is not given so much importance. Indoor environment, nobody is going to give very much importance to indoor environment, although it is very very essential nowadays. It is becoming very essential, although it was essential earlier also. So many diseases uh, are the uh, the main cause of indoor environment. So poor indoor air quality leads to serious health implications and significantly affect the health and productivity of office employees. Indoor air quality is leads to serious health implications. So several diseases are occurring because of the poor indoor air quality. As per, if we see the data, if we see the studies, several studies, we find that many diseases are occurring because of the poor indoor air quality. Indoor air is in fact more polluted than outdoor air. Indoor air means the air, the atmosphere within the close proximity of our building or in our home, inside the home, inside the building, inside the office, inside the mall. So indoor air quality is very poor, and it leads to serious health implications. So much attention over indoor air quality is required to be given. Indoor air quality is affecting the health and in fact productivity of office employees also. If poor air quality will be there, then office employees cannot give better productivity also. So several good industries, good offices, and reputed organizations, they consider this effect also, indoor air quality parameter also, in the evaluation of productivity of their employees. Or they several is you can find several studies in which productivity is shown to be affected by the indoor air quality. And to meet the standards of indoor air quality, several measures are also taken by the industries, offices also. And for these measures, we need energy. So ultimately, indoor air quality is one aspect. Another aspect is energy requirement to maintain the set standards of indoor air quality. So we need huge energy to meet the quality of indoor air, which is not which is required to have a good health, to prevent the occupants from the bad effect over health, and also to increase the productivity of the employees working in that atmosphere. If we see that the literature available in the journals or in the papers or in the form of over the internet, we find that the indoor a person, major part of a person, major time of a person, of a human being, is spent indoor. So it is about 90% of the time is spent within the building or indoor. So we are facing that environment for 90% of the time. Only 10% we are in the outdoor environment. And indoor environment is more polluted than the outdoor environment. So it is a very serious issue that indoor air quality must be good enough so that we can live healthy. So maintaining a safe level of indoor air quality in the buildings is an ongoing challenge. So it is now becoming a a big challenge for us to maintain indoor air quality. We are not still aware of the indoor air quality. We are not giving due consideration to indoor air quality. Most of the citizens of India and me and most are not in fact aware of the indoor quality, and those who are aware, they are not able to either they are not able to maintain the indoor air quality, or they are least worried about the indoor air quality, although they are getting the bad effects of it. Several lungs diseases, asthma and lung diseases are occurring because of the poor air quality, poor indoor air quality. So we have to give due consideration to indoor air quality. Indoor air pollution. So, according to the WHO, World Health Organization fact sheet, indoor air pollution is one of the main reasons for respiratory diseases and premature deaths in developing countries, contributing to nearly 40 lakh deaths annually throughout the world. So, indoor respiratory diseases, and in fact, I have seen in some literature that cardiac problems are also occurring because of the poor indoor air quality. So, indoor air quality is leading to is the major cause of cardiac diseases also, apart from the respiratory diseases, lung diseases. So, heart diseases, lungs diseases, they are poor indoor air quality is contributing to those diseases. So it is uh, an alarming situation when we need to have a good indoor air quality by uh, any means. We may use active systems which are consuming the conventional form of energy, that is electricity, or we may go for with the green energy, renewable energy also. So we have option for the renewable energy sources to provide the good air quality without continuously consuming, without the need of money, without the need of uh, must much expenses. So in most cases, the culprit is particulate matter 2.5, PM 2.5, tiny invisible pollutants that hang in the air for a long period and are many times smaller than the diameter of the human air. So indoor pollutants are in the form of PM 2.5. You must have heard about the PM 10 and PM 2.5. So particulate matter 2.5, they are very tiny particles which we cannot see easily. They are much smaller, many times smaller than the diameter of human hair. So we cannot see it. And these particles are present in indoor air in a good quantity if if we are burning fuel inside the home, if we are uh, using even LPG gas, then we that is also contributing to PM 2.5, although its percentage is very low. But if in case of combustion of the coal, or the combustion of wood, or biomass, the indoor air contains high quantity of PM 2.5. And PM 2.5 are very small particles. We can inhale those particles, and they can directly go into deep into our lungs. So PM 2.5 can settle deep in the lungs, causing respiratory illness and even cancer. So it is a major cause of lung diseases. Studies show that PM 2.5, poor indoor air quality, is a major source of respiratory illness or diseases. The National Human Activity Pattern Survey suggests that people spend almost 90% of their time indoors. So major part, almost 90%, we are spending indoors. Effective Interventions need to be made at behavioral, technical, and policy levels to reduce indoor air pollution in India. Now, how we can get a good indoor air, or we can reduce the indoor air pollution? So that can be done by behavioral levels, technical levels, policy levels. So we can adopt good technical technology. We can or the policy good policy may provide us reduced indoor air pollution in India. This could well start with increased awareness about the quality of the air we breathe and its effect on our well-being. So we must have to become aware of the quality of the air which we are breathing and its effect on our well-being. Then only we would be further spreading the awareness, or we would be contributing to provide to have a good indoor air quality wherever we are spending time, whether it is office or it is a workplace or home or some shopping space. So everywhere we need to be aware. We may ask the shopping malls. We can desire to get the air quality labels. We can ask to have the level of quality of air in the shopping spaces, also office or in offices we can demand for the quality of air. So we have to spread awareness, and we have to make best efforts to have demand for a good air quality inside the indoor. Strategies to improve indoor air quality. So what are the strategies? Strategies are pollutant source control. So where from the pollutants source should be identified, and from the source itself we can control the pollutants. So the major source is kitchen may be a major source. Our different windows maybe the major, maybe the source of pollutant. So we would need to identify the pollutant source so that we can control the pollutant from the source itself. Then increased ventilation is very important aspect. This may also improve the indoor air quality. In many houses, we can see that there is no ventilation. They are very much closed in nature. Their architecture, their design is totally closed in construction, and the ventilation is uh, not possible, and the ventilation is not seen. So it is highly dangerous for those who are living in such environment in which ventilation is poor or no ventilation is taking place. So we need to increase the ventilation to get the indoor air quality, a good quality of indoor air. Dehumidification. Humidification is water vapor present in the air. So we need to dehumidify also. Humidity control. Humidity should also be controlled as per the ASHRAE requirements. A perfect defined criteria of humidity is given. 60% humidity gives us the better, a good comfort, and humidity should also be maintained. It is also a major cause of diseases, bacterial and virus diseases. They can uh, disperse or distribute, or they can further grow in the humid environment. So dehumidification is also important to have a good indoor air quality. Use of air cleaners, dust collectors, filters. If the situation is very critical, if the indoor air quality is very much very poor, such as in restaurants, if the kitchens are closely associated with the restaurant, then and if the ventilation is not proper of all in industries, in several industries, if the ventilation is not proper, then it may lead to very poor indoor air quality. So they need to use the air cleaners, dust collectors, filters, to so that the indoor air quality could be improved, or the finest particle of contaminant, which is PM 2.5, must also be removed continuously, and it's regularly its concentration or its density must be checked. So now we can see that in Bhopal also we have several at several places continuously air quality is being checked, and air quality index is also displayed. Air, but in indoor environment we are not in fact aware, and we are not having any information about the air quality level in indoor. So as of now, we could understand the indoor air quality, and the need of good quality of air uh, in within the building, inside the room, or inside a house and offices. Room air ventilation. Ventilation moves outside air into a building or a room and distributes the air within the building or room. So ventilation is just exchanging. It is a process by which we can exchange the inside air from the indoor air from the outdoor air. But outdoor air should also be clean, and studies suggest that outdoor air is comparatively cleaner than the indoor air. Indoor air is more polluted, so we need to exchange the indoor air continuously. Why it is more polluted? Indoor air is more polluted because indoor we are spending huge time inside the indoor, and uh, because of the different human activities within the indoor, we are polluting the indoor environment. Indoor environment is getting polluted. We are using kitchen, we are burning fuel, we are breathing so many. So because of the human activities, breathing also exchanging the pollutants, dispersing the pollutants. So if several persons are living in a house, then everybody is contributing in the biological or some pollutants in the indoor environment, and they are not being removed. If ventilation is not taking place, then they are accumulating or recycling. If we are using fan, then those airborne particles or the contaminants are recycling 4 to 5 times continuously. They are getting recycled within the environment. So we are continuously getting the poor air quality, as well as continuously the contamination is increasing. So ventilation, exchanging of indoor air quality is very much required, so as to get a fresh air, and to reduce the concentration of the pollutants in the indoor atmosphere, indoor environment. So ventilation is very, very essential, and nowadays it is more becoming important, since uh, we are consuming, we are using energy, and we human activities have increased. There are different activities are continuously contributing in the contamination of air, indoor air. So ventilation is becoming more and more important. The general purpose of ventilation in buildings is to provide healthy air for breathing by both diluting the pollutants originating in the building and removing the pollutants from it. So as I have told you earlier also, ventilation in buildings provides the healthy air for breathing. The commonly used types of ventilation. So ventilation may be established by the natural ventilation system. Natural force drives outside air in natural ventilation. It may uh, take place by the mechanical means, which is called mechanical ventilation. So mechanical fans drive mechanical ventilation. Blowers are there. Blowers are used to continuously uh, suck the air or force the air from the indoor environment. So continuously air can be removed from the through the fans with the help of fans or blowers, or can be induced from the with the help of induction fans, induced fans. So air can be replaced, indoor air can be replaced from the outdoor air. Hybrid or mixed mode ventilation uses both the natural as well as mechanical ventilation systems. So this was just information for the information so that we can understand thoroughly all the aspects of ventilation and requirements of ventilation, indoor air quality, so that we can focus on the ventilation, passive ventilation with the help of solar energy. Solar energy for ventilation in buildings. So we can also use solar energy for ventilation in buildings. Ventilation is very essential. We have already seen, and its need also we have seen. So solar energy, which is abundantly available on the earth, easily available to us, that energy can be used for the ventilation at free of cost. So more energy from the sun falls on the earth in 1 hour than is used by everyone in the world in 1 year. So it is said that 1 hour, in 1 hour, the energy obtained from the sun over earth is more than the energy used by everyone in a year. So huge energy is being obtained by us on the earth through sun, which is freely available. We need not to pay anything for the sun, for the solar energy. The most commonly used technologies for solar energy utilization in buildings includes solar photovoltaic. We can generate electricity with the help of solar light. So solar photovoltaic is one of the major application of solar energy. Solar water heating. Solar water heating also takes place in many places. Many people, at many requirements, we use solar energy to heat the water. Passive solar space heating, cooling, and ventilation. This is a unaware part of solar energy. Still, a few who are pursuing research work, who are doing research work, or who are in the teaching community or in the academics, they might be knowing about the passive solar space heating, cooling, and ventilation. Otherwise, it is totally unaware. So common person do not know about this system, about the solar space heating, cooling, and ventilation. But it is having great opportunity. It is having great scope, and it is very much effective also. So through passive form, we can use the solar energy to heat the air, to get the heating, cooling, as well as ventilation. So in this lecture, we would be focusing on this third part of the solar application: solar passive space heating, cooling, and ventilation. So passive solar ventilation. This is the topic which we have to discuss today in this session. And before that, all whatever I have told you was very much required to as a background to better understand this topic and to get to know the importance of this system, passive solar ventilation system. So this is basically a strategy which rely on the use of heat of the sun to produce ventilation without the use of external energy source. So in passive systems, we don't require any electrical energy or conventional source of energy. We use just solar energy, and ventilation takes place with the help of the heat obtained from the sunlight or solar energy. So this solar energy or thermal energy is being used for the ventilation to take place and for the motion of air or to establish the flow within the indoor passages. This is called passive solar ventilation because unlike active ventilation systems, it does not involve the use of mechanical and electrical devices. So in active systems, we use mechanical and electrical devices, but in passive systems, only a stationary system works and it does the work without the consumption of any conventional form of energy. Another important aspect which is also required to be known before fully understanding the concept of passive, fully understanding the advantageous concept of solar passive ventilation system, we need to know about the EAHE system also, Earth Air Heat Exchanger system. This is also very popular. This is also very effective system and getting popularity also among the researchers nowadays, but going to become popular among the common person also. Those who are getting aware of this system, they are going to use, and some are still using. And it is also not new. It has been used by the olden architecture, and in the system, outdoor air is used. Outdoor air can be further cooled or heated before entering into the building spaces. So in an EAHE, Earth Air Heat Exchanger system, outdoor air is drawn into the building through a system of tubes laid into the soil underground near or beneath the building. So in the system, tubes are laid under the ground in the soil so that the thermal effect from the soil can be obtained in the air. And these systems are not any newest technology, but the concept is being used, dates back, used in Roman architecture also. So centuries ago, in Roman architecture also, they have used this concept. They were not using the term earth air heat exchanger, but they were using the same concept. So this concept can be used, and huge energy, conventional form of energy, can be saved. So nature has given everything. Nature has given all the alternatives. Only we need to just understand the nature, as I had told in my previous session, previous session. We had seen that we need to understand our nature, environment, everything is there. We have everything, we have every solution, alternatives are there, and they are really useful. Rather, depending upon the conventional or high grade of energy, we can use the system concept or conventional technologies, non-conventional technologies, using the renewable energy sources, and we can get all the benefits, all the comforts, our requirements can be fulfilled, our human activities can be easily performed with the help of naturally available resources, naturally available technologies which are using the natural nature. So these systems are also very much effective in providing cooling and heating of air. So in this diagram, you can see there are two types of earth air heat exchanger system. One is said to be open loop system, and another is closed loop. In open loop system, the continuously fresh air can be supplied to the building or spaces, while in closed loop, the room air is recirculated, and the advantage from the soil or underground soil can be obtained through the pipes. So air is supplied to the underground laid tubes, where from it comes with the lowering of temperature or increasing of temperature, and air can be cooled or heated from the soil uh, uh, and heating and cooling effect is obtained naturally. So we need not to use any high grade of energy, or we need not to use electricity for the cooling and heating of air. No great temperatures differences can be obtained. A substantial appreciable change in temperature of air can be obtained through these systems, and both are effective systems. They are proven systems. So many researchers have worked upon these systems, and they have found that systems are reliable, they are effective, efficient, and they are the future technologies. They are also going to become future technologies, because energy will not be so cheap, or will not be reliable also in future, uh, as record says, as reports from the IEA says that it is very difficult to say that future energy requirements or future energy security cannot be said right now, since the conventional fuels, fossil fuels are limited in stock, and we are relying upon the import of the fuels. So it is difficult to say about the future availability of energy from the conventional sources of energy. So we have to rely on the non-conventional energy sources. We have to upgrade the technologies. We have to start using the non-conventional technologies, so that it could become popular, and we can get the easy solution of the our requirements also. So, if we see more about the Earth air heat exchanger, the Earth has been used as a sink. So, thermal sink since the ancient times. So, apart from the other thermal sinks, as air, atmospheric air, oceans, Earth is also a good thermal sink, thermal reservoir as a sink. Since the ancient times, in about 3000 BC, the Iranian architects have used wind towers and underground air tunnels for the passive cooling in about 3000 BC. So, um, earlier architects architecture was using this technique for the heating and cooling of buildings, and over the time, we have become more dependent upon the active system and electricity, and the causes might be some industrial causes, political causes, uh, and because of those causes we have adopted these technologies, active systems, and forgot the usage of passive systems. This technology has also been used by the ancient Greeks and Persians also. For instance, the Italians in the Middle Ages used caves called colvoli to pre-cool, preheat the air before it entered the buildings. Still, there are several structures, buildings, old age structures, where these effects can be seen. So they are this technology is very effective, and this technology has proved that it is effective, it is reliable, and it is long lasting. It is no need to invest. We need not to invest continuously in this technology. With limited expenditure on the maintenance of such systems is required, and no continuous consumption of no need of conventional energy is also there in the systems. So use of solar chimney is passive in passive solar ventilation. Now we come to another part of the system, solar chimney, which is called solar chimney. Now we have learned about the earth air heat exchanger. I'm going to show you one more system, solar chimney, which is also very much effective in passive solar ventilation system. A chimney is a type of passive solar heating and cooling system that can be used to regulate the temperature of the building as well as providing ventilation. So solar chimney is also a system which is used for heating and cooling of air. And apart from heating and cooling, it can also provide ventilation with the use of solar energy. They are easy in design and manufacturing and inexpensive means of ventilation in a building. So solar chimney, with the use of solar chimney, we can get passive solar ventilation apart from heating and cooling of air. So we can get the heating effect of, or we can get hot air in case of winters, and we can get the cooling effect in case of summer season with the use of solar chimney. So through this figure, I will show you how the solar chimney works and about the construction of solar chimney. So solar chimney is basically a system which uses solar energy, the heat energy of the sun, and it provides the motion of air because of the change in density, because of the buoyancy effects. So with the help of solar energy, we heat the air in a passage. It may be a rectangular passage like a duct, in which a solar absorber plate is there. A plate or the bottom surface of the absorber of that channel absorbs the solar energy, and this heating effect of the absorber plate heats the air, the adjacent air. So the air adjacent to that absorber plate becomes hot, and because of the buoyancy effects, it flows upwards direction, in the upwards direction. And this flow of air sucks the air from the inlet of the all the openings in the building. So we can get a motion of air can be driven. So this air driving can be obtained from the solar energy with the help of solar chimney. So solar chimney is a structure, or we can say this is like a duct or a tube or a rectangular passage which absorbs the solar energy, which is having a plate as an absorber plate and a transparent sheet. So through that transparent sheet, the solar energy enters into the solar chimney, and absorb that energy is used for the driving of air, and this flow of air provides the ventilation in a room. So this is very effective system. This is a stationary system. Passive means we need not to have any active system, blowers, fans. No need of such systems are there. In the use of solar chimney, so air will flow automatically with the help of solar energy. Heat transfer and airflow rate through solar chimney. So as you can see that the passage the solar chimney passage is having an absorber plate. Absorber plate may further have different structures so that its effectiveness can be improved. It is normally painted black, and it is normally kept rough. And in fact, some more modification can be done on absorber plate to make it more effective, and more heat transfer can be obtained. Heat transferring properties or absorbing properties can be further improved with the improved absorber plate by providing artificial roughness. If we keep the surface rough, then more energy can be absorbed by the plate, and this heat energy is transferred to the air adjacent to the plate. And when the air adjacent to this plate becomes hot, it flows upwards because of the density difference, and pulls the colder air from the building spaces or room spaces. So we get the ventilation effect or airflow effect with the help of solar chimney. So solar chimney is a prominent, is a very effective means of providing flow to the air, and we can get the air motion or ventilation in a building. Performance of solar chimney in providing ventilation. So we see the results of solar chimney, as many researchers have obtained have worked upon the solar chimney performance of solar chimney. I have also worked upon the solar chimney along with my research scholars, and at a PhD level, and at many at MTech level, and uh, we have also experimentally worked over solar chimney, and we have found good results. We have obtained good results. A prototype solar chimney of size 2.41 meter by 1.49 meter by 0.26 meter. This is a small prototype. Supply the airflow rate of about 40 to 60 meter cube per hour during a hot summer day. So huge airflow rate can be obtained with the help of solar chimney. In many places throughout the world, they have used solar chimney to drive the turbine also. So solar chimneys may also be used to drive turbines, and may also be used to get the electricity. Electricity can be produced with the help of solar chimney. These provide so much good effect, so much good airflow rate, that the rotor of the turbine can be rotated with the help of uh, moving air. It can produce a heating effect in the indoor environment up to a temperature difference of 8 to 15 degrees centigrade from the ambient temperature. So, solar chimneys can also be used to heating and cooling of the indoor environment. We have got these results. These results are obtained by us only. Although in literature, on in available literature researches, you can get good results from the different solar chimneys. When solar chimneys are coupled with an earth air heat exchanger system, it provides the effect of temperature change up to 15 degrees centigrade in the indoor environment. So if the solar chimney is coupled with the earth air heat exchanger system, then we can also get the good cooling and heating effect in adverse weather conditions. In summers, we can get cold air if the solar chimney is coupled with the earth air heat exchanger. We can get hot air in winters from the this combination of solar chimney and earth air heat exchanger. So these are totally passive. They are totally dependent upon the solar energy. Earth air heat exchanger system is also somehow dependent upon the solar system, solar energy. They are also based upon the solar energy. Earth is absorbing solar radiations, and it is getting hot or cold in different weather conditions. So these and they are working. Earth, the soil of the earth can be used as a thermal reservoir, as a sink, where heat storage can be stored, supplied, and rejected without the appreciable change in the soil. So we can remove any part of, we can reject any amount of heat in the soil, in case of if we require the cooling of the air, and we can also get the heat from the soil if we require the heating effect. So these solar chimney, and along with the earth air heat exchanger system, may be used passively to get the heating, cooling, and ventilation effects. We need not to rely on the conventional source of energy or electricity. There is no need of electricity. You can get these effects throughout the day with the help of this passive system. So these are very effective system, proven system, and many are going to become aware and going to use these systems in their premises. Several offices, buildings have been coupled with the earth air heat exchanger and solar chimneys, and many researchers are also further working. Many designers are also working to associate these systems with the already built buildings, already built established buildings or new buildings are now being designed with the provision of these systems by the architects. So architects are also using this technology. Those who are aware of these systems, they are incorporating these systems, they are incorporating the design in their systems, and it is very easy at the time of construction of new buildings to incorporate these systems without any appreciable investment. You need not to make any major investment in adoption of these systems, and already established buildings or spaces may also use these systems with little change or little modifications. So these systems are totally passive and promising techniques to provide low cost solution to the buildings in providing ventilation, heating and cooling. So now I have reached up to the concluding remarks points. Now we can conclude whatever we have learned in this session. So whatever I have told about the solar passive ventilation system. The passive solar ventilation is a promising green technology using energy of sun to provide heating, cooling, and ventilation in a building passively. The technology is a simple and effective since it is not involving any use of conventional source of energy as electricity. This will provide sustainability or sustainable environment. So as this whole short-term training program is focused on the sustainable solution or environmental sustainability. So these my both of these sessions are contributing to provide the solution or making all the faculties and all the participant aware of the technologies, the passive technologies, the requirement of adoption of these technologies, usage of renewable energies and these techniques, so that we can keep our environment sustainable. We can have that sensitivity over the environmental sustainability. So I hope I could have contributed a little bit in making you all aware about the, or I could inculcate somehow the sensitivity towards the sustainability of environment through
Yes,
both
sir.
of my sessions. So this was
Thank
our
you,
report.
sir.
Thank you.
Thank you, sir.
Thank you.
Okay, now the forum is open for question, answer, and queries.
Please ask if anybody is having any query, any doubt, or any further clarification over the points, whatever I have discussed in my session. You will please ask.
Sir, I
On,
have a question.
yeah,
You talked about solar chimneys.
yeah.
So, what could be the minimum size, cross-sectional size of a solar chimney?
Solar chimney, solar chimney can be designed according to the requirement of the building space actually. So that requires a little bit knowledge of the calculation. Little calculations are used to get the to get the size of solar chimney, and for that we need the building, how the building, the design of the building is to be considered, the shape and size, or the placement solar chimney, how the where the solar chimney can be placed, as solar chimney should be placed towards the facing the south side, and how much space is there. So some criterias are there, and with the consideration of those criterias we design the solar chimney. Although as I had told you, this the performance of a prototype of chimney, which is almost 2.5 meter long, and its width was about 1.5 meter, and thickness was 200 mm. So this was sufficient. This is providing a good airflow rate, air exchange rate. We see the air changing rate, air change per hour. Then it is providing sufficient ventilation to a room of size about uh, 20 by 10 by with a 10 feet height. So
So
this is a
solar,
typical size.
yes, sir. Solar chimney can be used for ventilating a single space, or it
Single
can
space.
be a centralized one.
Centralized also, it can be connected with different building spaces. It can be designed for a rooftop solar chimney shape, and with the this solar chimney can be connected to various building spaces. Various suppose if a centralized solar chimney is placed over a roof, over a rooftop of a building, then different building spaces may be connected through pipe, through duct. So every space will get the ventilating effect through that solar chimney.
So,
So
can we plan for a small plot sizes also, like a 30-50 plot, or
yeah, definitely, definitely. Uh, but that the size, the shape and size of the chimney will depend upon the design of the building,
yes,
building space. So how you are going to design the building. So with the little consideration of those building spaces and building the utilization of spaces in a building design, we can design a building. So minor modifications will be there only in a solar chimney according to the different design of the solar chimney building spaces.
okay, thank you, sir.
Thank you. Anybody else? If
As you have shown in the diagram that it is a slit is cut in the roof
hmm,
for the chimney.
hmm.
So can we take it in the vertical wall, the south side?
Definitely, we can also get the same effect if we place the solar chimney at the south wall of the building.
Okay, sir.
Actually, we get better effect if we place, if we tilt the solar chimney at a particular angle, so that we can get the maximum heating effect from the solar radiations. So normally it is placed at in Bhopal. It should be kept at an angle of 21 to 23 degree towards facing south.
Okay.
But if you can place, or you can make a flow passage along the south facing wall, you can also get good effects.
Okay, sir. Because of the rain flow that we have to shift not on the roof but on the side so that rainwater we can protect from the rain.
Rainwater can be protected to enter into the solar chimney by providing some shelter for some we can that can be managed over solar chimney, so that
Mhm.
rainwater will not enter into the solar chimney. Some sort of hood can be provided over the exit of the solar chimney. So that is easily the approach that can be easily modified the solar chimney, or the so rainwater can be prevented.
Okay, sir. Thank you, sir.
Thank you. Welcome. So I
Okay,
yeah.
yeah. Okay, anyone else who's want to ask any question?
In future also, if anybody if you have any query, or if you further want to study more on these solar chimneys, or anything else, any system regarding earth heat exchanger or solar chimney or passive ventilation system, you may in future also you may contact. Madam is having my details, and you can get my details, my phone number, email ID also. So, and I will share my PPT also. So you can get any support in future also in these technologies, in the usage of this technology, in further information about these technologies, or if you want to pursue some research work also, you can get my support at any time.
Thank you, sir.
Uh, Sir, do you have executing team who can execute these structures?
Uh, we are providing all the support, technical supports as a presently. So many researchers are working under with me, along with me. So we can provide the solution. We can provide the consultancy also if any for any if anything required. If any technical support is required, so we are having a good team of researchers and those who have worked under with me. So we can provide any sort of solution, any type of designing work, or any support, any technical support regarding these systems.
Thank you, sir.
So, I am Chimney from Jharkhand. Here, solar chimney is not available. So, I want technical support service. Please give here, sir, Jharkhand.
Jharkhand.
Yes,
So what type of support, whether you want to design a solar chimney, if you want to.
yes, ma'am. Solar chimneys. Uh, सोलर चिमनीज कैसे यहाँ पर इस्टेब्लिश करने के लिए किससे बात करना पड़ेगा और क्या इन्वायरमेंट का सेफ्टी के लिए, तो वो सब चीज के लिए मुझे टेक्निकल सपोर्ट सर्विस चाहिए सर।
ठीक है, उसको है ना आप अपन है ना आफ्टर दिस सेशन, और है ना जब आप चाहें तो इस पे अपन है ना मैं आपको बता दूंगा कि कैसे सोलर चिमनी को डिजाइन किया जा सकता है। यू कैन लर्न दैट टेक्निक ऑल्सो, और अगर आप अपनी रिक्वायरमेंट्स बताएंगे तो हम वी कैन ऑल्सो सजेस्ट कि हाउ द सोलर चिमनी कैन बी ऑब्टेन, एंड इट इज वेरी इजी टू गेट मैन्युफैक्चर दिस सोलर चिमनी। सोलर चिमनी को बनाना बहुत आसान है। हम लोगों ने भी जो अपने रिसर्च वर्क में काम किया है, हमारे साथ रिसर्चर्स ने काम किया है, तो हम लोगों ने खुद बाय आवर ओन हैंड्स और विद आवर सपोर्टिंग जो भी हमारे साथ सपोर्ट में थे, उन लोगों ने सपोर्टिंग रिसर्च स्कॉलर्स थे, तो उन लोगों ने मिलके और जो हमारे को जो इक्विपमेंट और मटेरियल सप्लाई जिन्होंने किया, सप्लायर्स जो थे, उनकी मदद से बहुत इजीली इट कैन बी मैन्युफैक्चर्ड। बहुत आसान है। तो आप मुझे बताइएगा फ्यूचर में जैसा आपका हो, मैं आपको आई विल गाइड यू, आई विल प्रोवाइड ऑल द डिटेल्स एंड द relevant things to get the solar chimney at your place.
Thank you very much, sir.
Thank you.
Yes, Shahid sir, do you want to ask a question? Yeah.
सर, आपने भोपाल में की प्लान किया आपने क्या सोलर चिमनी का?
हाँ, भोपाल में हम लोगों ने मैंने अपने LNCT कॉलेज में भी थोड़ा सा इसका प्रोटोटाइप पे काम किया था, और हम लोगों ने मैंने स्टूडेंट से बनवाया था। वी हैव गॉट द प्राइजेस आल्सो, और एक बड़ा ही पूरा एक हमने प्रोटोटाइप यहाँ पे बनाया हुआ है गवर्नमेंट वुमेन्स पॉलिटेक्निक कॉलेज में। तो वहाँ पे पूरा सेटअप है, इट इज़ फुल्ली फंक्शनल, एंड उसमें हम लोगों ने काफ़ी सारा इंस्ट्रूमेंटेशन भी किया हुआ है, जिससे कि वी कैन गेट द रियल टाइम डेटा। हम उसके सोलर चिमनी का परफॉर्मेंस का देख सकते हैं, और उससे कंटिन्यूसली रिसर्च डेटा जो है वो भी हम वी कैन ऑब्टेन द रिसर्च डेटा, so that we can further study the different parameters of the solar chimney, and we can optimize the design of solar chimney. As different solar chimney designs are to be used according to the building requirements. So we can modify the solar chimney, orientation of the solar chimney can be changed with our established research facility, at Bhopal, and we can get data of performance of solar chimney for all weather conditions throughout the year. So we are having a good system. शायद सर आपकी आवाज क्लियर
हाँ,
नहीं।
आवाज आ रही है सर आपकी। सर,
हाँ भाई,
भोपाल में अगर मैं देखना चाहूँ, लाइव साइट देखना चाहूँ, तो क्या पॉसिबिलिटी है?
हाँ बिल्कुल बिल्कुल, आप वुमेन्स पॉलिटेक्निक कॉलेज जहाँ पे ये प्रोग्राम
Yes,
ऑर्गेनाइज
sir.
हो रहा है।
Definitely, sir. You
ओके,
are always welcome, sir. Most welcome, sir.
जी,
ओके, थैंक यू सर।
बहुत
We
अच्छा
can proudly
सिस्टम
say
है।
that, yes, sir. We can proudly say that what we are discussing toward this contribution towards sustainable environment. So we are already practicing and started practicing in some of the areas in our campus itself. So in the previous session also, which was about the biocomposting, that also we have established in our campus, and this passive ventilation system is also established in our system with the help of Bhartaria sir. And you can, anyone can, anytime can come at our campus to see this establishment, and even the performance can be checked here.
Wow.
बहुत
Very
अच्छा
nice.
सिस्टम है, फुली फंक्शनल। और आपको मैं यहाँ बताऊं कि ये है ना, जो वहाँ के पॉलिटेक्निक कॉलेज के सभी लोग हैं, फैकल्टी, सपोर्टिंग स्टाफ, प्रिंसिपल साहब का तो बहुत ही योगदान है। और सबने मिलके, सबका इसमें मॉरल और फिजिकल सपोर्ट है। सबने है ना इसको मिलके एक है ना प्रोजेक्ट जैसे किया है, और इतना अच्छा सिस्टम बनाया है, इतना अच्छा अर्थ है हीट एक्सचेंजर का और सोलर चिमनी का बना है, कि जिससे कि आप इस टेक्नोलॉजी की जो इम्पोर्टेंस है, इस टेक्नोलॉजी के डिफरेंट एस्पेक्ट्स हैं, फीचर्स हैं, रिलायबिलिटी इश्यूज हैं, तो ऑल दोज इश्यूज कैन बी अंडरस्टूड, और उनको आप फीचर्स को देख सकते हैं। यू कैन फील कि हाउ इफेक्टिव इज दिस सिस्टम. So we are continuously getting the data, and we can analyze the data and get the reflection of that system in terms of its performance. तो कभी भी किसी को भी मौका मिले भोपाल आने का, वुमेन्स पॉलिटेक्निक में आपको आने का, तो यू आर मोस्ट वेलकम। आप देखिए सिस्टम को और फर्दर स्टडी करिए उसमें। और मैं तो कहूँगा कि जो ये बना है उसमें आप फर्दर यू फाइंड सम स्कोप टू गेट इट मोर इफेक्टिव, और इसमें क्या मॉडिफिकेशन किया जा सकता है इससे कि इसको हम और बेहतर बना सके। अपना कंट्रीब्यूशन भी दीजिए इसमें, मैं तो बोलूँगा।
सर मैं पूछ रही थी
जी।
कि आप लोग जो वहां पर कंस्ट्रक्शन किए, ये तो क्या विभाग से अनुमति लेकर करना है क्या? विभाग, डिपार्टमेंट से?
आप उसके लिए है ना वहाँ पे संस्था में एक पूरा एक टीम है, तो आप है ना कोऑर्डिनेट करिए सब बातें कि कैसे कर सकते हैं। आप भी अपनी जगह में आपके यहाँ की क्या प्रोविजंस हैं, क्या कंडीशंस हैं, तो यू कैन गेट गुड सॉल्यूशन आल्सो, है ना। यू कैन बेटर अंडरस्टैंड कि अगर ऑफिशियली यू हैव टू डू, तो हाउ यू कैन गो अहेड विद द डेवलपमेंट ऑफ दिस एस्टेब्लिशमेंट ऑफ दिस सिस्टम।
थैंक यू वेरी मच सर।
थैंक यू, वेलकम मैडम। So I think I could have yeah, शायद सर।
सर, आपका सोलर चिमनी सिस्टम जान के बहुत अच्छा लगा मुझे। थैंक यू सो मच। और सर, आपका कॉन्टेक्ट नंबर जानने के लिए मैं बहुत उत्साहित हो चुका हूँ मैं। तो कैन यू प्लीज शेयर?
Yeah, I will share
Madam,
contact numbers of all the speakers with you.
Madam will share all the details.
Okay, thank you so much, sir.
Thank you.
So thank you very much, sir, for very informative session. Passive solar ventilation is an upcoming area of intervention. Not upcoming, but it is very traditional way. But we forgot it to incorporate in our designs, and now again we are going to it because now the energy demand is going up and up, and there is again we can say the energy crisis we will observing in coming future. So thank you very much that you have nicely explained the concept behind it and how this technology is going to help us in reducing our conventional energy demand. So thank you very much, sir, for providing us such a good information and giving us your precious time for this program and this session. Thank you very much, sir.
Thank you very much for all the participants also, those who have contributed and listened me. Bhutala sir, good afternoon sir.
नमस्कार सर, नमस्कार।
नमस्कार सर।
नमस्कार
कैसे
सर।
जी सर।
सर बहुत बढ़िया। और आपने ये जो अभी बातचीत में हमारे पॉलिटेक्निक का जिस तरीके से नाम लिया, हमको बहुत गर्व महसूस हुआ।
सर आप लोगों के ही सबके एफर्ट्स हैं जिससे कि हम लोग इतना अच्छा कर सके और एक अच्छा सेटअप बनाया, और many of the researchers will definitely get benefit of this system and this facility.
नहीं, वो आपके गाइडेंस में पूरा सब लोगों ने जैसा आपने बताया, तो आज हमको बहुत गर्व महसूस हो रहा है। जब आपने झारखंड वालों को बताया और उनको बताया, तो हम तो चाहेंगे सब लोग आए, हमारे कॉलेज में विजिट करें और अपना फीडबैक भी दें, ताकि हम और काम को सुधार सकें अच्छे से।
बिल्कुल सर, ये तो शुरुआत है, अभी बहुत करना है सबको, और सब लोगों को अपनी अपनी जगह पे करना चाहिए, और इसमें भी सजेस्ट करना चाहिए, कंट्रीब्यूट फर्दर करना चाहिए, सो दैट हम इसको ग्लोबल लेवल पे भी हम सोच सकते हैं कि कुछ मॉडिफिकेशन सजेस्ट कर सकते हैं फर्दर, सो दैट इट कैन बिकम मोर इफेक्टिव एंड यूजफुल एंड एट लो कॉस्ट आल्सो। सो थैंक यू वेरी मच सर।
धन्यवाद।
Yeah, thank you very much, sir. Just I want to announce tomorrow's session. Tomorrow we will be having our session from 10:30 onwards. First session will be of architect Jay Thakkar from SEPT University Ahmedabad, and second session will start on 12:15 p.m. It will be taken by architect Shikha Patidar ma'am, and third session will be at 2:30 p.m. It will be taken by architect Tapas Upadhyay. So we will join at 10:30 tomorrow. Before that, please put your attendance on Google form. The link is provided to you on the WhatsApp group. Thank you very much, and good day to everyone.
Thank you very much, ma'am.
Thank you.